WindTech is the first episode of this Lumière webinar series. We hope you all grab the best out of today's event for a better tomorrow. So let me introduce our guest speaker for the first episode of Lumière, Engineer Sudath Chandana. Engineer Sudath Chandana graduated with honors degree Electrical Engineering from the University of Moratuwa. He is a chartered electrical engineer and a member of Institution of Engineers Sri Lanka. Also a member of the Institute of Engineering and Technology, UK. He was appointed as Chief Operating Officer of WindForce PLC in 2021, prior to which he was the Chief Technical Officer WindForce PLC since 2009. Having commenced his career at Sierra Construction Limited as an electrical engineer in 1998, he later in 2000 joined John Kills Computer Services as an analyst programmer. Later, in 2002, he joined LTL Holdings Private Limited as an electrical engineer and performed duties of a project manager for various projects during a 7-year tenure. Furthermore, he is an accredited renewable energy consultant for Sri Lanka Sustainable Energy Authority, and also he holds certification for wind resource assessment by Technical University of Denmark and solar resource assessment by PV SIST Switzerland. It is very clear that he has many experiences on the field of renewable energy as well as wind energy specifically. So join hands with us to hear about the past, the present, and the future of wind energy. Dear sir, I cordially invite you to enlighten with us with your wisdom.
Good evening, everyone. First of all, I am thanking everyone at IEEE Power and Energy Society, and especially Professor Janaka Ekanayaka for inviting me to share my experience and knowledge on renewable energy. So let me share my screen and start my presentation to share my knowledge and experience. I hope you all can see my screen, shared screen.
Yes, sir, we can see the screen.
Okay. Okay. I think renewable energy is one of the most, speak topic these days, because we have at the moment fuel crisis, because we all are experiencing power cuts at the moment about 3 hours per day, and we don't have any. We are having a foreign currency shortage to import diesel or any other thermal energy required for power generation. So this is the most, the topic during these days, how we can implement renewable energy in Sri Lanka and connect to the grid to at least get some ease for this current crisis. Let me start my presentation with this. My content will be, I'll be speaking a little bit about history of wind power usage, then the current status of wind energy, and then the wind potential of Sri Lanka. So then you will understand how we have, neglected this resource for last decade or so without implementing or using this resource available to us. And then I'll be talking about how we have to do, or how we can implement a commercial scale wind power project. Okay, if I talk about history, with the records The beginning of wind power usage goes to about 5,500 BC. They have used sailing boats and ships. Then the vertical axis wind turbines or devices, they have used somewhere around 1000 BC for grinding and water pumping. Then again, some vertical devices used in Asia for, especially for milling. Then if we talk about Sri Lanka's wind power usage, our ancestors, they have used wind power to smelting for smelting iron. That is somewhere around 5000 BC. So this technology has disappeared after 11th century for some reason. Then the vertical axis devices again used in somewhere around 5,500 to 900 AD for water pumping. Here are some wind turbines which used in Asia, Europe in somewhere around 1000 AD. Here is another picture of some old wind turbine used in Europe. Okay, let's see how this current wind turbine has evolved. It has something around 1980 to 90. The turbine capacity was somewhere around 75 kilowatts. Then it has come to today's wind turbines like 5,000 kilowatts or 5 megawatts. And if we see the wind turbine diameter or the diameter of blades from 17 meters to now today's wind turbines, which the diameter is around 170 or 75 meters. Let's see what are the biggest turbines available today. I think a few weeks ago, one of the leading wind turbine manufacturers, they have launched their largest onshore wind turbine, 7.2 megawatts. The rotor diameter is 172 meters. If you take the hub height or the height of the wind turbine, then depending on the size, it can go up to 175 meters from 112 meters. Wind turbine class is S. And then the starting wind speed or the cutting wind speed is about 3 meters per second. If you talk about the offshore wind turbine, now today's turbines are in the scale of 16 megawatts and the rotor diameter of 262 meters and the hub height of 143 meters. Let's see how the world total wind installations has evolved. From 2001 to today, it has come up to, by 2020, it has gone up to 743 gigawatts. I think now it has gone beyond 850 gigawatts, the total installed capacity all over the world. Let me show you how this regional, the continent-wise wind turbine total installed capacity has evolved from 2010 to 2020. you can see how the Asia is leading now, especially China and India. Our neighbor India also has many number of megawatts installed, but still we are lacking. Total our installed capacity is somewhere around 240 megawatts. If we talk about our Sri Lanka's renewable energy policy, we had a policy earlier. Our target was 20% by 2022. Then last year, it has changed to 70% renewable by 2030 and 100% electricity generation from renewables by 2050. This is our energy policy, but still we don't see any progress towards achieving this target because of some policy issues and some technical issues and many more. Okay, as I said earlier, let's see what is our potential. USAID and US Renewable Energy Laboratory, they have done a survey about Sri Lanka's wind potential somewhere in early 2000. According to them, their report, we have 20,000 megawatts potential, which is only if we consider the good and excellent sites, especially from regions from Puttalam to Mana and then to Jaffna. And we have some capacity in Hambantota area as well as the center of the country. And with this map, you can clearly see how our potential distributes. You can see here in Puttalam area and then Mena and the belt, the northwestern belt from Puttalam to Jaffna, how we have the potential. Especially mainly due to the southwest monsoon and the center of the country as well. This is another resource which we have. If you go to the Global Wind Atlas, you can see our wind potential, and you can see our potential from here, this northwestern belt as well as the southeastern region, Hambantota, and the central region. Okay. If I talk about the first wind power plant in Sri Lanka, Ceylon Electricity Board, CB, started their pilot project somewhere in 1995-96. They did a pilot project of 3 megawatts in Hambantota. You can see some old pictures of this project. They had 5 wind turbines of 600 kilowatt each. But unfortunately, that wind power plant is no more in operation. So then after about 14-15 years, some private sectors started renewable energy development. They had talks somewhere since 2005, but the commercial scale wind power plant implementation started somewhere in 2009 and 10. You can see how as I said earlier, our total installed capacity at the moment is 230 megawatts, including this 100 megawatt CB wind power plant, which was commissioned last year. You see this in 2010, there were 3 wind power plants, each of 10 megawatt, were commissioned. Those are in Putlam and Norachole area. Then again, 2011, 2012, and 2000. After 2014, you see again there is a lack of development. And after this 230 megawatt, there is another 1 wind power plant is coming. It is only a 15 megawatt. After that, we don't see any developments in the wind sector. That is very unfortunate. Okay, then I will go to the project development aspects. This is the wind power plant development cycle. So what we have to do initially is we have to see do some pre-feasibility studies and prospecting. Then we have to do a wind resource assessment. And then with the resource assessment, we have to do the siting, we have to start with permits and environmental approvals, we have to study the logistics, and most importantly, the grid interconnection. Here I will be mainly talking about Sri Lanka's potentials and how we have to do projects in or develop a wind power project especially in Sri Lanka. And then we have to do the financing as well as the power purchase agreement. Then once the power purchase agreement and the financing in place, we have to start with the engineering, procurement and construction process. Either we can do it by ourselves or we can contracting it to a third party. And then the construction, installation and commissioning. And once the power plant is commissioned, we have to do the operation and maintenance for whatever the years we have agreed with the utility for. Here in Sri Lanka, it is 20 years. So if I talk about feasibility and prospecting, first we have to identify the regions with the wind potential. So there you have to use the publicly available wind resource maps. For that, Global Wind Atlas is one of the best resource available, freely available. From there, you can see the regions where the wind potential is available. But later, you have to do detailed study to identify the specific points required for selecting wind turbines for that specific area and for the particular wind regime. And then during the pre-feasibility study, again, we have to study the tariffs. But in Sri Lanka, earlier we had the feed-in tariff. Then they changed it to the tendering. but there are plus and minuses of both the systems. Then again, they are going to implement the feed-in tariff as well. Then the land availability, because when you are doing the pre-feasibility, one of the other important aspect is the land availability. For a wind power project, you have to have enough land and then the logistics. Because let's say if we consider our central region, we have good wind resource, but we have logistics issues. We have to transport this heavy and lengthy wind turbine components. It is a very difficult task. With the available technology in Sri Lanka, I can say it is almost impossible. But in the other regions, there are options, technologies available. You can do the logistics very easily. And then the licenses. One of the important license is the environmental approval. There you have to see whether your identified area is whether it is under forest reserve, or it is a wildlife reserve, or it is a restricted area. Whether those are near airports or any other restricted regions. And then, at last but not least, the grid interconnection costs. Because our, grid availability, or we have to plan where we are going to connect our wind power plant. There you have to see at what voltage we are going to connect. At the moment, with the limitations we are having, the allowed interconnection voltage is 33,000 volts. But then you have to see the capacity available at the particular grid substation and the transmission line costs. Today, if we consider today pricing, the transmission line cost is somewhere around 8 to 10 million LKR per kilometer. So that also we have to consider if you don't have easy access to a nearest grid substation. Let me explain you more about the wind resource assessment. Once you do your pre-feasibility study, now you have identified the particular area where you can see you have good wind resource and you have the access to the grid, and you consider logistics are okay. Then what you have to do is you have to measure the wind at least for 12 months. If it is a bigger project, let's say for 25 megawatts or 50 megawatts or bigger project, then you need at least 2-3 years of wind data. Here we consider this 12 months as a one full cycle, because in Sri Lanka we have 2 monsoons and the other time is inter-monsoon timing. Our main wind timing, we are getting southwest monsoon from May to September, October. Then we have inter-monsoon period again from December to February. We have northeast monsoon. During this period, we have very good wind. Then during the wind resource assessment, you have to measure at least 10 minutes wind speed, and you have to decide the measurement levels depending on the currently available wind turbines. Because today, the smallest available commercial turbine is somewhere around 3 megawatts or bigger. So then you have to see what are the hub heights available. Then you have to decide on the number of wind measurement equipment, wind speed measurements, and the wind direction measurements. You have to decide on the heights. Then you need the ambient temperature, humidity, and the barometric pressure. Those are the minimum basic requirements for a wind resource assessment. Here I'm showing one of our very recent wind resource assessment sites. We did this from 2020, 2019 to 2021 for one of our wind projects in Mena. Those days, available hub height was 90 meters. So we installed wind speed measurement at anemometers at 90 meters, 70 meters, and 30 meters, and then the direction at the same heights. When you are measuring, you have to consider some other aspects as well, some technical aspects, like you can see a lot of guy wires coming down. Those guy wires are used for the stability of the wind mast, and then the anemometers and wind vanes shall not disturb by these guy wires. Okay. Then the project implementation. Then you have, once you have your wind resource done, then you have to select a suitable turbine. With that turbine, you have to do micrositing and then the land acquisition. And then parallelly, you have to start with the EIA or IEEE or whatever the environmental approvals and the other permits and approvals from local authorities or the central governments. And then you have to do a logistics study depending on your selected wind turbine size and the grid connection. Here I am giving example of 10 megawatt wind project, which is under construction at the moment in Mena. So here we did the wind resource assessment for 1 year. Actually, this wind project is totally 15 megawatts, but with this our regulations, we have to divide it into 10 megawatts and 5 megawatts. I am giving here for this 10 megawatt example only. Here we used 2.5 megawatt machine. The machine model is GW 2.5 from Goldwyn, China. The generator is with permanent magnet generator. Hub height is 90 meters. The diameter is 121. It is 100% variable speed. Number of turbines for this 10 megawatt is four machines. Average wind speed after wind measurement for 1 year is 7.5 meters per second at the hub height of 90 meters. And the air density of 1.225 kilograms per meter squared. And turbine spacing is around 700 meters. The expected plant factor is more than 30%. This is how we came up after wind resource assessment. Once we put all this data into our resource assessment software, we could do this analysis. You see, you can clearly see the southwest monsoon and then the northeast monsoon. It is that not that dominant like southwest. We are getting most of the energy from the southwest monsoon. This is some calculations that we did with the turbine model. We had to correct the air density to the site-specific air density of 1.145 kilograms per meter cube. You can see the turbine class and the rated wind speed and some other technical parameters. As I said, we use the WASP software, WASP software from DTU Wind Energy, Denmark. With that, once you put all your measured wind data, you can see whatever you can specify the hub height, and you can see the wind resource density at that particular site at the given hub height. Then you can place your wind turbines and see the wind resource. You can do the wind resource assessment. This is the results we obtained. You can see from this 10 megawatts, our net energy, estimated energy is 40 gigawatt hours per annum. Even you can see once we did the microsighting, the average wind speed which each of the turbine is getting, and the energy generated by each of the wind turbines. You can see it here. Likewise. These are the locations which we have placed the wind turbines. So approximate distance between two turbines are 700 meters. Let me show you our approval process. This is one of the difficult tasks which we are facing during the project implementation. Or if you are to develop a wind power project in Sri Lanka, you have to get all these approvals, and some of the approvals you have to obtain several times, more than 1 or 2 times. Okay, let me explain. First, you have to obtain a provisional approval from Sustainable Energy Authority. If it is not a project awarded from a tender, let's assume it is with the feed-in tariff, then you have to get the letter of intent. Then if you are expecting tax exemptions, you have to go to BOI, get their approval, and you have to sign an agreement with them. Then you have to go to environmental authority for environmental clearances. Then if the project is near to sea, or then you have to go to coast conservation department. Then public utilities permission for generation license, particular Peradeniya Sabha for construction license. Then you have to get the survey plans from survey department. If the land owned by the government, let's say if your project is nearby a area reserved by forest department, then you have to go to forest department. Anyway, you have to get the no objection letter from forest department. Then civil aviation authority, you have to get air clearance, whether they will clear you, whether there are any airports nearby or you are not in a restricted zone. Then the wildlife, especially for birds, migration paths and any wildlife reserves. Then the irrigation, agrarian services, archaeological. Likewise, this is minimum of 24 clearances. Then the logistics. As I said earlier, once you decide on the turbine, you have to get the details from your supplier, the weights and the lengths of turbine components. So you have to see the blade length and the tower components and the heaviest components like generators. What are the weights and dimensions? Then you have to see the local transport path, whether there are any bridges or anything which they have any limitations on the maximum load transportation. So let me give you some examples for this ongoing project, which is in Mena. We have got down the equipment to Trincomalee because we cannot transport those components from Colombo. We have many restrictions. The length of the blade is 59.5 meters, and the heaviest components are somewhere around 60 to 70 tons. So we have some restrictions and some overhead bridges. We have some height limitations as well. So we decided to go with the Trincomalee port. We got down the turbine components to Trincomalee. Then, as you can see here, we have several paths, but we decided on this route, which is shown in blue color, because of some limitations in the road. See, here we face major problem, how we can transport our 60-meter blade. 59.5 meter blade. So we had to bring down a special equipment which can handle the blades even at smaller, narrower beds. This can tilt the blade where you cannot take the turning curves. And once you get the turning curve, you can lower the blade again and march. And then again, there are some lengthy as well as you have some height restrictions. You have to increase the heights of crossing transmission lines and telecom lines. And some roads, you have to widen the bends to take the turning curves. And then the grid interconnection. In this case, we were given the grid interconnection at Mana grid substation at 33 kV level. Then we have to decide on the path as well as the conductor, whether we are going with aerial bundle conductors or the bare conductors, depending on the local restrictions. And then I will explain you more about the construction process of a wind turbine project. Some of the pictures which I have used are some old pictures, but all these pictures are from Sri Lanka only, other than that blade adapter picture, which are some old pictures from wind turbine power projects in Sri Lanka. Here you can see the internal, because when you have number of wind turbines, you have to transport the wind turbine components as well as the erection cranes. There you need to extend or widen the not available. You have to construct roads. Those are the practical issues you are facing when you are doing. Then you have to consider the weights, and also you have to consider the rainy season, because during the rainy season, this area may get flooded. See, some of the areas you don't even have a road. So you have to construct road, a brand new road. And then depending on the turbine size and the soil conditions, so you have to decide whether you are going with your foundation type, whether it is a file foundation or a raft foundation. That before that you have to do a proper soil investigation. Once you have the soil investigation done, then you have to have a design, proper design for the foundation. And then depending on the soil, you may have to strengthen the bottom soil or remove some soil and strengthen it, or go with the pile foundations likewise. Here you will see the turbine anchor for the foundation. This will be embedded to the concrete, and the rest of the components or the tower, and the rest will come on top of this. Here you see the turbine foundation construction. Depending on the design, you will decide whether it is, as I said earlier, raft or the concrete raft. And during the concreting, you have to maintain the temperature to avoid cracking and any other aspects specified by the civil designer. Here you see the completed foundation. Then the turbine erection. Depending on the crane, depending on the turbine heights and weights, the heights, you need a crane. If I take this our Mana power project, our crane requirement is 700 ton and 110-meter boom height. The picture given here is some old picture from our first wind power project in Putlam. There, the hub height was 60 meters, and crane requirement was only 350 ton, and the height was 70 meters. And then you have to install or erect the turbine tower components piece by piece. Then the nozzle, where you have the generator and the other components. In this case, we have a gearbox as well in the nozzle. Then you assemble complete rotor on the ground and erect it to the nozzle. Here you see a completed wind farm picture from one of our Putlam wind power projects. I'm just showing you our completed wind power plants. Another 15 megawatts by end of this year. Pictures and details of our wind power projects. This is one of the first wind power projects in Sri Lanka. Which was 10 megawatt. Turbine size was 800 kilowatt. We have 12 wind turbines. The hub height is 60 meters. So the rotor diameter is 59 meters. This is the other wind plant, which is adjacent to the previous one. The same turbines, and the capacity is 10.4. Altogether, we have 20 megawatts there. And then this wind power project we commissioned in 2012 in again Putlam, Kalpite area. Then the fourth one, which is next to the well-known CB coal power plant, Norachole. Total installed capacity is 12 megawatts. And hub height there is 85 meters and rotor diameter is 82. There we have used permanent magnet generators, and with the lower rotation speeds, we are not using gearbox there. This is again power plant in Putlam. Then again we have another 2 projects in Jaffna. Total installed capacity of 24 megawatts with a similar machine. So I'm going to conclude my presentation here with the time given to me. Some of the things I have not covered the technology part because of the time limitation. So you can ask questions, then I will explain with my experience.
Thank you very much, sir, for sharing your valuable knowledge on the matter. And now it's time to begin the Q&A session. So within the last hour, we have delightfully got a couple of questions from our participants. So still, if any of our valuable participants have any other questions or concerns regarding the wind energy, please feel free to unmute yourself and ask your question. So the first question was, is it practical to implement household wind energy sources and develop it?
Yeah, actually, that all depends on your requirement. There are some household smaller size wind turbines available, but then it all depends on your requirement. So let's say but the other thing is then at the moment in Sri Lanka, you are not allowed to connect household wind turbines unless it is a hybrid system. That is the other thing.
Okay, thank you, sir. And the next question was, what will the job market in the wind energy sector be like in the future?
What do you mean by in Sri Lanka or globally?
I think if you can explain both, it will be better.
Yeah, if you consider Sri Lanka's market, now the government is going to open, the feed-in tariff again, and there are many permits. There are many permits issued, energy permits are issued for projects below 10 megawatts. And then there was some expression of interest calls last year, November, for projects above 50 megawatts. Both local and international companies have expressed their interest to implement projects above 50 megawatts, and some proposals for even offshore projects. But the local situation, as we all know, with the current crisis, since government is offering LKR tariff, so it is doubtable that international players are coming for these bigger projects, unless government is giving USD tariff. But for the locals, local companies or developers, they are willing to implement. But the issues they are facing is the US dollar or the foreign currency non-availability to open the LCs, and volatility of the LK, I mean Sri Lankan rupee. Even we had some recent issues for this Mana wind power project. We bid that LKR 9.48 for the unit price for kilowatt hour. That was in 2019. Then we had the offer from that particular turbine supplier. Now we were given the approval on 2021. By the time, due to pandemic and other issues, the prices has gone up, but we had some tariff increase with the USD exchange rate, but the increase in the logistics, I mean the freight cost, those are the problems. All the other developers again facing the similar issues due to this volatility of Sri Lankan rupee, as well as the material prices increase internationally. Those are the issues which we are facing. But when you consider the international market, one thing is especially China, they are developing their own projects. So when you look for wind turbine components or the supply of equipment, you have to wait for a few years to get down or there for the delivery. Because now they have taken over all the wind turbine manufacturing market. But when you consider the countries in Europe or let's say India, all the countries are going towards renewables, especially wind and solar, and offshore wind as well.
Thank you, sir. We've got another question. Where is the development of bladeless turbines heading?
Yeah, actually, I don't have much experience on that subject. There were some research and developments on vertical turbines. Even we did some trials, but those were not very successful. Even when you see today's, this horizontal axis wind turbine development, hope you saw my slides. These bigger turbines, they are coming up. If there are any other developments for this vertical axis or any other bladeless turbines, then they should have come up by now.
Yes, sir. So moving on to the next question. As well as onshore, wind turbines are placed offshore. What are the benefits of doing so?
Benefits are like because when you are having onshore turbines, especially, you have to have land, then you have logistics issues. Likewise, but when you are doing it in offshore, especially, you don't have any land issues, and more resources are available offshore. And then you don't have any, especially the environmental issues like preservations or like wildlife or any other reservations, forest reserves. You don't have to use those when you are doing the offshore. And you can go for bigger sizes of turbines. And the disturbance to the public also very less.
Cost-wise
More
also
environmental
is
friendly.
cost-wise also is there a benefit?
No, cost-wise, it depends because if you go for a very smaller turbines or smaller project sizes, then those are not feasible. But if you can go for bigger projects like more than 100 megawatts, then more feasible to go with offshore. Even for a country like Sri Lanka, if we can go for offshore, then I think it is more feasible. But we have some other issues like foreign currency and other technical issues like grid non-availability.
Thank you, sir. So we have another question. What can we do to minimize the effect of wind turbines on wildlife, such as birds?
Yeah. Yes. One thing is because you have to, when you are doing the micrositing or when you are doing the initial studies, you have to avoid those areas. But then, let's say, if you are in the buffer zones or nearby zones, then there are technologies like, when there are birds coming, you can stop the turbines because most of these migratory paths are the migratory paths are in some part of the year only. Even this CEB Mana project, they have installed some radars to detect birds and stop the turbines when birds are coming towards the turbines. Technology is available.
Thank you, sir. As the final question, we have, as an engineering undergraduate, how can we find a job in the wind industry?
Yeah. Okay. Toughest question. So, first thing, it depends on your appetite. Like if you are willing to go for a renewable, if you have a passion to go for renewable, then that is one thing. But when you consider Sri Lankan market, there are only few players or few projects are ongoing. At the moment, as I know, only 2 projects, renewable energy projects are ongoing. One is our 15 megawatt Mana project, and the other one is 10 megawatt solar power project in Betiklo. After that, we don't see any projects coming up. And the other thing is because there are very good market overseas. If you have a passion or if you go for higher studies, then you can do your masters or some further studies on renewable energy. Then there are a lot of opportunities overseas. But as a, engineer in Sri Lanka in the renewable energy sector for last 10-15 years, I don't see much prospects for undergraduates with the current situation in the country. But who knows? Maybe in a few years' time, by the time you all are, graduating, if the things are going to get better, so there may be more opportunities in Sri Lanka. At the moment, we are not in a position to, comment about our country's situation, more uncertain. Not only the renewable energy market, everything.
Yes, sir. Thank you very much, sir, for clarifying all the doubts we've had. I would like to invite all our enthusiastic participants to kindly fill out the feedback form, which will appear on the chat box now. Thank you. So before winding up today's session, I would like to thank Engineer Sudath Chandana on behalf of our society for being here with us today to share your knowledge and experience with us to enlighten us despite of your busy schedule. Sir, we couldn't have asked for a better person to conduct this session. I also would like to take this moment to extend my gratitude towards our advisor, Professor Jamika Ekanayaka, and our senior treasurer, Dr. Prabhat Binduheva, for their continuous support and guidance throughout the way. Thank you, sir. Last but not least, we would also like to thank all the participants who joined hands with us today. Hope to see you all in future events too. Thank you, everyone. Stay safe.